Next one, perhaps even one that is entirely different from ours. Theories of the multiverse are nothing new in the world of astrophysics. But evidence for this theory is the James Webb Space Telescope just released the first image of another universe. And we're now sharing with you the latest facts about this sensational discovery. Stay tuned, it's going to get exciting. What's really out there? What's really out there? Since the dawn of time, humans have looked up at the stars and pondered about the sun, the moon, and the stars. For the first humans, the sun and the moon were holes in the sky through which light came into a world that these people imagined as a disk. Over millennia, our species has found out that we live on a ball that rotates and revolves around a star that is also a sphere, and together with many other stars and planets, we are a tiny part of a large galaxy and an even larger cosmos. Even though we have had high-powered telescopes for about 100 years, we still do not know everything about space. Researchers are constantly discovering more phenomena in the universe. They find answers to old questions, yet many mysteries remain unsolved. To this day, we don't know who created the universe or why, and we didn't know until now whether the universe has an end or is endless. With our best telescopes, we have so far been able to see about 13 billion light years away. When we look, we are always looking back in time because the light that telescopes like Hubble capture has traveled through time and space to reach us. We see the image of the moment when the light began its journey to us. This look into the past is fascinating. In this way, researchers were able to look back almost to the birth of the cosmos. At least that's what they thought for a long time. And then came along James Webb, the new space telescope from NASA, the Canadian Space Agency, and the European ESA, which began operation in the summer of 2022. Even the first images from the telescope provided explosive material that still sparks heated discussions among scientists today. To be exact, there are 6 galaxies that are supposed to have existed at the beginning of time, for which there is no scientific explanation. Galaxies like Glass Z13 already existed 250 to 350 million years after the Big Bang, and that's theoretically impossible. At this point in time, there should have only been a few stars slowly grouping together to form entire galaxies. Several billion years would be necessary. What does this mean now? Is the theory of the Big Bang wrong? Or is there a completely different explanation? Indeed, there is one. We may be looking at another universe here. What does this image show? What does this image really show? The image of the galaxy cluster MAX 0647. JD reveals a breathtaking view of a group of galaxies. Like precious gems, they sparkle in the vastness of space. What truly excites scientists about this image are not just its beauty, but the facts. The same region of the universe was already imaged a decade ago by the Hubble Space Telescope. However, the quality of the image wasn't quite as informative, and in particular, the old and reddish objects in the background couldn't be decoded. It was only clear that they exist, and that was strange enough. The gravitational lensing effect, where small and distant objects in the background are magnified by objects in front, told researchers that these blurred points of light were old and very old indeed. James Webb then revealed stunning new details thanks to the triple lensing effect. Galaxies so old, so bright, and so highly organized that our Milky Way seems rather ordinary in comparison. Today, researchers were particularly puzzled by the data on the brightness intensity. If the interpretations are correct, these galaxies have produced 100 times more stars than our galaxy. All the rules of astrophysics failed at this point. It's as if scientists have built all cosmological worldviews around an assumption that now clearly proves to be false. This is a shock for those who believed in the existence of a single universe and assumed that everything within this universe could be explained with the equations of Einstein's theory of relativity. Meanwhile, other branches of physics have long postulated that it's much more likely for us to live in a universe that is just one of many, with many additional dimensions or universes that could exist alongside or even within our own world. These galaxies might contradict our physical concepts because they belong to a completely different cosmos and exist within a completely different time structure. Glass C12. One of the first newly discovered galaxies was Glass C12. Galaxies are usually named after the research systems through which they are discovered. GLASS stands for Grissom Lens Amplified Survey from Space, and C12 indicates the value of the redshift. Each research group uses slightly different designations, and it's not obligatory, for instance, to provide the redshift value of a newly discovered galaxy. Galaxies can also receive simple numerical designations. To laymen, Z12 may sound unspectacular, but astronomers hold their breath with this abbreviation. This value means the galaxy already existed 300 to 400 million years after the Big Bang. Therefore, it's very old and, according to current cosmological theories, seemingly impossible. The discovery of glass C12 was already celebrated as a sensation in the scientific community, but even more ancient and peculiar galaxies followed. Schrödinger's galaxy. Schrödinger's galaxy, Sears 93316, seems to top all the inconsistencies. This object is so old that it already existed 250 million years after the Big Bang. However, this object exhibits another peculiarity. Measurements of redshift yielded two very unusual results. At one instance, the object showed a redshift of 16.7 Z, indicating extreme age. Then, measurements of objects in the vicinity of Sears 93316 were taken, and based on those, the galaxy displayed a completely different redshift. The galaxy appeared as if it existed in two places and two times simultaneously. Scientists jokingly refer to this galaxy as Schrödinger's galaxy, inspired by the famous quantum physicist Erwin Schrödinger, who demonstrated that at the quantum level, two or more realities can exist simultaneously. According to these theories, it's not only normal to have two universes, but there are infinitely many in many times and countless locations. Scientists struggling to grapple with these measurement results and new perspectives would still prefer to believe in a measurement error, or even doubt whether these points of light are galaxies at all. While the spectroscopy examination to confirm the redshift is still ongoing, further data analysis from James Webb's NIRCam system has already definitely ruled out the possibility of it being a low-mass star or an unobstructed active galactic core. We must anticipate that the discovery of Sears 93316 was only the beginning of what is possible. NASA has suggested that the JWST, James Webb Space Telescope, theoretically can detect galaxies with a redshift greater than 20. These galaxies would have existed only 200 million years after the Big Bang. Or perhaps the telescope is peering even further into dimensions of our universe, which might confirm that we have encountered a boundary of time and space unrelated to the Big Bang at all. Able 2744 Y1. At this point in time, we can no longer speak of the beginning of time, the universe, or the time after the Big Bang. Instead, we adjust the terminologies and refer to it as the edge of the observable universe. There lies another fascinating source of light, which exhibits a very high redshift value in our images. To prove that Able 2744 Y1 is indeed a galaxy whose light has traveled more than 13 billion years to reach us, a group of researchers has combined the best telescopes in the world. The Spitzer telescope, Chandra, and Hubble have captured another image of this remarkable galaxy by collecting data from various wavelengths of light and assembling them into one image. Not only is the age and distance of this galaxy intriguing, but the rate of star formation surpasses anything previously deemed possible in physics. Despite being 50 times smaller than our own Milky Way galaxy, Able 2744 Y1 produces stars at a rate that is 10 times faster than that of the Milky Way, which is atypical for a galaxy in a young universe. The observable universe currently has a radius of 46.1 billion light-years. Beyond that, there is likely much more. The better our telescopes become, the further and more detailed our observations can reach. James Webb is theoretically capable of looking back 13.6 billion years. If the Big Bang occurred 13.8 billion years ago, there would eventually be a limit to our observations. This is because several 100,000 years after the Big Bang, the universe would have been completely dark. The first stars are believed to have formed only after 380,000 years. If researchers continue to discover even older galaxies, it will conclusively prove that all previous cosmological assumptions were wrong. Currently, scientists at NASA are gaining initial experiences with the new telescope, which have already been astounding. However, We know that time always brings new experiences, and in 1 or 2 years, scientists might be able to extract even more from the telescope's capabilities. Then, perhaps we could finally see what truly happened at the alleged beginning of time. No beginning and no end, only transitions and thresholds. Although the theory of the Big Bang seemed plausible for a long time, there was no evidence to support its accuracy. With the rise of quantum physics, it became even more likely that our universe is an incredibly changeable, diverse, and possibly multi-layered place. Models of the bubble universe or pocket universe propose that our cosmos is enclosed in a large bubble and shares space with many other bubbles of various sizes. The pocket universe assumes that within a cosmos, there are multiple segments where similar but also different physical conditions may prevail. Through these pockets, we could access other dimensions or corners of the universe where different laws apply. In fact, there are nearly as many pieces of evidence and clues for these theories as there are for the Big Bang theory. The assumption of the Big Bang and the rules of Einstein's physics were established long before the theories of quantum physics. Irregularities in the inflation rate of the cosmos and in the cosmic background radiation, dedicated scientists found evidence for other dimensions and universes that seem plausible. That's why the discovery of impossible galaxies is such an exciting thing. It's like finding a hidden treasure that either leads us to confirm old assumptions or reveals entirely new worlds. Which type are you? Are you more inclined towards confirming everything old and being within a secure scientific framework? Or do you find theories of the multiverse and the unpredictability of the cosmos much more thrilling?